Welcome to Ask and Learn.
This is the answer to Chapter 21, problem number 42 from the Smith Organic Chemistry textbook. And this problem is a naming problem. So we're given several structures and asked to come up with the IUPAC name for each structure. And so the way to do this, of course, is to identify the longest chain or the main ring, and then name each of these molecules as a derivative of that longest chain or of the ring. And so looking at the first one, that's an 8-carbon chain with a phenyl substituent and a ketone. And so we want to give the ketone the lowest number. And so that's going to be carbon number 3. And so that would make the phenyl group at carbon number 8. And then we'll just fill all that information in. So this is going to be 8 phenyl, 3 oct, because it's an 8-carbon chain, and then it's going to be octanone for the ketone. Octanone. Okay, and so that's A. So then looking at B, we have a 5-membered ring. We have an aldehyde, and of course we'll want the aldehyde to be substituted at carbon number 1 of the ring, and so that's going to make our methyl group at carbon number 2, and so this is going to be 2-methyl cyclopentane. And then remember, the way that we name these aldehydes is going to be to call this carb aldehyde. So 2-methyl cyclopentane carbaldehyde. All right, so then moving on to C. This is going to be a 6-membered ring. There's a ketone in the ring, so obviously that will be carbon number 1. So then we're going to have a methyl group at carbon number 2, and then that's going to put our ethyl group at carbon number 5. And so we just put all of those pieces of information together and make sure that we are listing our substituents in alphabetical order. So rather than 2-methyl 5-ethyl, this is going to be 5-ethyl 2-methyl, because E comes before M in the alphabet. So 5-ethyl 2-methyl cyclohex for our 6-membered ring, enone for our ketone. So 5-ethyl 2-methyl cyclohexanone. So then moving on to D, what we see for D is a 6-membered ring with an aldehyde, and then a benzyl substituent at the next carbon over. There's also stereochemistry here that we should include in the name. So these groups are trans to one another. And so we're going to start the name of this molecule with that. So this is going to be trans 2, because the carbon with the aldehyde coming off of it is going to be carbon number 1. So our benzyl group is going to be on carbon number 2. So this is trans 2-benzyl. And then cyclohexane for our ring. And then carb aldehyde for our aldehyde. All right, so that's D. So I'm actually just going to do a new page rather than try to squeeze stuff in. So that's D. So then for E, um, again, we have a 6-membered ring. This time it's an aromatic ring. Um, and so it looks like we have an acetyl group and nitro group, and they are ortho to one another. And remember, because it's an aromatic ring, we would use ortho meta para designation rather than saying 2 nitro. And also, because it's an aromatic ring, we can call this acetophenone. And so this is going to be O nitro acetophenone. So O for ortho, nitro acetophenone. Another thing to bear in mind, since I'm drawing by hand, I can't really show italics, but the O here and the trans in D should be italicized. So if you're typing them for whatever reason, do make sure that you italicize them. So then part F of this problem, we need to identify the longest unbranched chain. 5, 6. So that's going to be 6 carbons with the aldehyde as our carbon number 1. So this is going to be a hexanal or hexanal. And there are 2 ethyl substituents, and they're going to be at the 3 and 4 positions. And so putting all of that together, this one's actually pretty straightforward. It's 3,4 diethyl hexanal. All right, and that's F. So then moving on to G. So again, the best place to start is to count our longest carbon chain. So it's going to be 8 here. And obviously we have a ketone. And 1, 2, 3, 4 versus 1, 2, 3, 4, 5. So the lowest number that we can give to the ketone is 4. And so making that ketone 4 is going to put methyl groups at carbons 2 and 5. And it's going to put this E alkene also at carbon 5. And so we'll start with that stereochemical designation. So this will be 5E 2 5 dimethyl 5 octane. Because remember, the 5E tells us what kind of double bond it is. 5-octane tells us how long the chain is and where that double bond is located. And then 4-one for our ketone. And that's G. And so H, again, we should start by counting carbons. So our longest chain is 6 carbons. We have an aldehyde and a double bond. And so it's not really possible to say what the stereochemistry around this alkene is because three of the groups are identical. So it's going to be a hexanal. So for the aldehyde and the double bond. So rather than hexanal, it will be hexanal. And there are going to be 2 ethyl groups and a methyl group. And so obviously the aldehyde is going to be carbon number 1. That makes the methyl group at carbon number 2. The ethyl groups at 3 and 4. And the double bond at carbon 3 as well. So then putting all of that together, what we get is 3,4 diethyl, 2 methyl, 3 hex N for the double bond, so En, not An, al for the aldehyde. And that's the answer to part H. And overall, that's the answer to chapter 21, problem number 42.